Okay, so today we are going to start ospf. It's a open standard protocol. Oh, sorry, open shortest path first. Full form is open shortest path first. So first of all, I will tell you, I told you the two protocol. First I said, first I taught about RIP. That was routing information protocol. Okay. Then I taught you EIGRP. Okay. So in RIP we had a problem. What we had a problem every 30 seconds he was updating his neighbor. He was sending message to his neighbor. Message or you can say update to his neighbor. So there was problem in RIP. And one more problem was there, only 16 device you can add. In EIGRP, what happened? First time it will send whole information. Sorry. First time it will send all information. Oh, yeah, information is correct, I think. And second time, it will, when any change will occur, when any change will occur, then it will send. Then it will send update. So let me draw what I am talking about because it's theory, you will not understand. I know. So see, if I have two router, if I am using RIP on both router, so what will be happen every 30 seconds? He will update each other. This process will not stop. It will continue whenever RIP will start. So there is a problem like memory will be full. Because if I am sending you every 1 second, hello, hello, message, hello, message, hello. So one time your phone memory will be full. You will say, please don't message me. And your processor also will hang. So processor, what we say? Uh, Processor problem, we can say. Okay. Because too much message every 30 second, every 30 second. So there was a big problem in RIP. So RIP is a, so and 16 router we can use maximum. That is also a big problem. So now they, what happened? They made, RIP is first, RIP was first one. Second, they made, I'm telling you, OSPF category protocol. OSPF was a linked state category protocol. So in this protocol, what they change? I have two router, okay? And in both router, here running OSPF. So every 5 seconds, five or 10, maybe 10 or 5, not sure about this. Okay, let's see, 10 into 3, 40 into 3, 140, huh? Yeah, every 10 second. Every 10 second. They will send hello message. Only hello. So it's not a big problem. But they will not share full information. In RIP, here, they was sending full information every 30 seconds. Someone message me. I am having issue with my no problem. Is Envy? Now in OSPF they are not sharing full information. They are sharing some information. Hello, 10 second every 10 second. So my memory will not full. First of all, it will not take too much processor memory. So everything would be fine. But when any change will occur, then it will send a update message. Only update. Okay. Even in update message, he will not share full information. So we improved this. Before we were sharing full information. Now we are not sharing information. We are sharing only partial information. If I have changed, so I will send update message. Otherwise, my hello is like a heartbeat. Every time he will say hello, 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 hello. They will only see my neighbor is okay or not. My neighbor is okay or not. So okay. So okay. So it was very slow. Convergence was very slow. OSPF is not a fast protocol. It's slow protocol. Now, engineer thought, yeah, OSPF is a good protocol. If we have unlimited device here, unlimited device I can add here, and for every task we have different message. So we don't need to share full information every time. So my memory will not full, my process would be good, everything would be good. But we need a fast protocol. Then what they did, I'm telling you only history. They mix OSPF and RIP. They combine two protocol. That's mean link state, it's a category of OSPF, and RIP category is distance vector. They combine two protocol. So if you combine two things, so we say hybrid. If you will combine two things, so we will say hybrid that thing. Like suppose that uh, nowadays we are making hybrid species. Okay, species like dogs. You can see hybrid dogs. We have some like they are like mixture of lion or dog, something like that. So we are making hybrid breeds. Same like here. We combine OSPF and RIP and we made hybrid protocol. That is EIGRP. So it has both functionality. RIP plus OSPF. Both functionality he has. If I am running router EIGRP on both router, two routers, so first time it will share full routing information. Full routing information. It will share all information. But First time they will share full routing information, but after that, when any change will occur, then EIGRP will send a update message. This time it will not share full information. So this we improved in EIGRP. So EIGRP is fast protocol. Its convergence is very fast. That's why in data center, still we are using EIGRP in data centers. Like if you will see, so mostly you will find EIGRP between switches, Nexus switches, and data centers. So EIGRP we still using. People say we are not using EIGRP, but it's not correct. Still in data center, we are using EIGRP because EIGRP is very fast protocol. Okay, that was little bit history. Now I am going for in my topic ospf. So ospf full form I already wrote. It's a open standard protocol. Open standards mean, I already told you, like any vendor can use this protocol. Any vendor can use. Vendor we have in routing, like in networking, like Juniper, it's a vendor. Cisco is also vendor. Aruba, it's a vendor. HP, Dell, all are these. I don't know, so much companies. Nexus, so much companies there. So okay, it's an open standard protocol. It's completed. Okay, it's a link state protocol. It's a category. It's link state routing protocol. Link state means where any change will occur, then ospf will send message. Otherwise, he will not do anything. So that is link state wait. It's a benefit of link state. Like if any change will occur, then it will send a message to the neighbor. Yeah, I got a change. Please do change. Let me explain you more. Suppose that again ospf is running, and here is a 10 network. Here is a 10 network on this R1 ospf running. So this like this 10 network was removed. This 10 network removed suddenly. There is a multiple reason. I don't know why it's removed, but it's removed. But ospf will send a message, only message, a update message, and it will say to R2 10.0.0.0 is not anymore. Please remove it. So R2 also will remove this 10.0.0. So this is quality of ospf. ospf will not send every time. In RIP, what will happen, if there is RIP, so there is like other network also 20, 30, 40, 50, 60, 70, 80. Suppose that other network also. So RIP will send full routing table. Remove. So you can see difference in ospf and RIP. Okay, so it's a IGP protocol. IGP. So in IGP category, we have three protocol. I think you guys already know. RIP, EIGRP, and ospf. There is one more protocol, but nowadays we are using, but I will tell you later. No problem. So mainly we use three protocol in IGP, internal gateway protocol. So IGP means internal gateway protocol. So we have three protocol in IGP, that is RIP, EIGRP. RIP you know, EIGRP you know. Now we are talking about ospf. Okay. For best path selection, for calculation of best path, it uses a metric, cost. Cost. It's a cost metric name. Okay, for calculation of best path, how he will calculate a best path? Which one is? I have three path. So which one is best path? So he will use this metric cost. That name is cost. Okay. I will tell you later how we can find cost. It's very easy to find a cost. Okay, let me tell you how you can find. Festus, what is the bandwidth of fast Ethernet? I think I told you yesterday or day before yesterday.
What was the question?
Yeah, what is the bandwidth of fast Ethernet? 100 Mbps. Okay.
Oh yeah, 100.
Yeah, I know. We forget. It's a not a issue.
Yeah.
Okay. Just try to speak. It's not a problem if we forget.
But the numbers were more than that. We just choose 100 from the numbers, right?
Yeah.
Okay.
Ethernet is 10 Mbps. And one more we have serial link. So it was very slow. Only 1.5 Mbps. So what is bandwidth? Link of capacity. Sorry, capacity of link. Okay, so this is a by default bandwidth. Now OSPF will not use this. OSPF use, his formula. So cost is equal to 100 by links bandwidth. Okay, if I want to know what is the cost of fast Ethernet. This 100 is reference bandwidth. It will be same every time. It will not change. Okay, if I want to know what is the cost of fast Ethernet, so what I will put in this formula. Fast Ethernet 100 Mbps. So reference bandwidth would be same always. So 100, it would be always same reference bandwidth. I'm writing here RF. Then links bandwidth. So fast Ethernet link bandwidth is 100. So 100 by 100. Do you know basic math? Guys? Guys, are you here?
Yeah. Yeah.
So what would be my cost if 100 by 100?
1.
Yeah, great. So this technique OSPF use to find out what is cost of that link. If I want to know about Ethernet. So cost would be same. Sorry, reference bandwidth would be same 100. Ethernet links bandwidth, it would be 10. Okay, 100. So cost would be 10 of Ethernet. So this way, ospf find cost serial link. Yeah, it's very difficult. So 100 reference bandwidth 1.5, it would be around 64. So always, largest cost is not good. Small cost, minimum cost is better. So this formula OSPF uses to find out cost. Okay. If okay, no. Okay, now I'm telling you one example. Let me tell you. Okay, I have R1, then R2, then R3, R5. Okay, maybe it's two. Okay, it is okay. 10.1.1.0/24. This is Ethernet link. This is serial link. We already know. Okay, so what is the cost of serial link? Could you tell me? So what is the cost of serial link? Could you tell me, guys?
Yeah, is it 64 equally?
Yes, great.
Yeah.
64. So 64. Okay, 64 and 64. Ethernet cost is, I will see there. Where is Ethernet first? Ethernet, yeah, this one. 10. Sorry. So I will write here 10. Okay, if I want to go R1 to here, so my total cost would be 64 plus 64 plus 64 plus 10. So OSPF uses like this. So 64, 64, 128 plus 64 plus 10. I think 192, if I'm not wrong. Yeah, 192. 192 plus 10. Now, 202. I'm right? So this is total cost. So how, like this OSPF work? Now it was basic. Let me show you little advanced how he will choose a best path. Okay. This is my R1 router. This is my R2 router. And this is my R3 router. Okay. This is my R4, R5, then okay. So I want to go from R1 to R3. I want to send data R1 to R3. Here to here. Okay. I know we are running OSPF. So this cost is 64. This cost is 64. This is fast Ethernet link. So its cost is 1, 1, and 1. If I want to go from upside, so cost is 128 at 64, 64. If I want to go from downside, 1, 2, 3. So which one is good, guys?
The 3 is closer by the number.
Yeah, 3 is lowest cost is always better. 3.
Yeah.
So this is SPF algorithm, which OSPF use. shortest path first. So it doesn't matter you have, you know, OSPF doesn't consider like you have 3 router, 4 router. It's work on how much you have speed. See there, I have here 3 link, but OSPF will choose this path because this is fast links. Here we have only 2 link, but they are slow link. So OSPF will not choose slow link. Okay, so this is we say SPF, shortest path first. So always remember, if you have 2 link and 2 link speed is, 2 link that 2 link speed is slow, so it doesn't mean your protocol will choose that link. Okay, if you have 4 link but your link is very fast, yeah, definitely your protocol will choose. So this is an algorithm which OSPF use for best path selection. SPF, first he will convert in cost, then he will find which is lowest cost. That would be best path. Okay, maybe theory part. Okay, AD value. So OSPF uses 1/110 AD value. Okay, I'm again telling you, RIP uses 120 AD value. EIGRP uses 90 and OSPF uses 110. So lowest AD will prefer. Lowest AD value will prefer. I am saying you again and again because I know we forget. It's not a big issue. Okay, it uses 2 multicast address. Every protocol use, 1 multicast address. It uses 2. I will tell you later why. Two to 4.0.0.9 and 10. Sorry, 5 and 6. By mistake, I got RIP 5 and 2 to 4.0.0.6. 2 multicast address it uses. Don't need to think about this thing. Why it use, why it is. Just only see it uses. Okay, one line. It is a classless routing protocol. I already told you about classless routing protocol. Classless means your subnet mask information will not change. Simply, your subnet mask will not change. Directly, we can write this. I already explained in one meeting. Classless and classful. In classless, there is simple way to understand. If your protocol is classless, okay, what happens if protocol is classful? So what will happen? Like you are using /24 value, but it will convert by default in /8. That's a /32. It will convert with /8, /27, whatever you are using. It will convert in /8. This is a drawback in classful. But if you are using classless routing protocol, So your information will not change. Subnet mask information. You are using classless. So slash 24. It would be slash 24. Slash 32, it will not change. It will be slash 32. Or slash 27, it would be same. So this is main difference between classless and classful. Subnet mask information will change in by default. By default is slash 8. And in classlet, your subnet mask information will not change. Okay, it's I told you in brief, but in my one video, I just talk about in deep. Okay, so next point is it uses SPF algorithm. Yeah, we already know. We have seen SPF algorithm. SPF means shortest path first. Again, I am writing. For best path selection, like every algorithm, if you are saying about algorithm, so every algorithm, it's shortest. Oh, sorry, for best path selection. Okay, in this protocol, we have three types of table. In this protocol, we have three types of table. First is neighbor table. NEIGHBOR, neighbor table. So how you can see neighbor? Same like EIGRP, show IP OSPF neighbor. And there is one more table, database there. I will talk about later what is database in this protocol. So show IP OSPF database. Now last one we have routing table, which every protocol you will found routing table. So show IP OSPF, sorry, show IP route OSPF. Okay, one more thing here. Let me talk about wildcard mask. Okay, wildcard mask. You guys know subnet mask. Subnet mask basically we use for divide our network. Uh, okay, so we are not going to thinking about this how we are dividing, how we are doing. Just I'm explaining you wildcard because it is in OSPF. That's why I have to explain you. Okay, suppose that uh, slash 24. How can I write this, guys? Could you tell me slash 24? How can I write? How can I will write?
In subnet mask,
Yeah, in subnet mask.
255.255.255.0.
Okay. Now I'm talking about this is subnet. So if someone will say me, what is the wildcard mask of this? So what I will do, I will minus in slash 32. Slash 32 means minus division, sorry, subtraction, sorry, what I'm saying. So I think 255 0 dot 0 dot. So this is my wildcard mask. So did you get how to find wildcard mask? Okay, let's see another example. Slash 16. This is subnet mask. And one person said me, tell me the wildcard mask of this subnet mask. So this is my subnet mask. I already know 255. So one person said me, tell me the wildcard mask. So what I will do, I will minus in slash 32. So it's not minus, subtract. Subtract is slash 32. Okay, let's subtract. 255 255 0 dot 0. This is wildcard mask. Okay, guys, could you tell me the slash 8? How you will find slash 8 wildcard mask? What would be my first step?
Zero,
Introduce
0. Yeah, if you start from there, yeah, 255. 255. 255.
Yeah, yeah. Basically, you can do, you know what you can do? In which place you have 255, you can put 0. And where you have 0, you can put 255. See there?
Yeah,
Just
that is what I
opposite.
did.
Just opposite.
Yeah.
Yeah, this is all, but this is, you know, a real technique.
Mm,
But this is a shortcut.
yeah.
Like if I want to write again slash 24, and I'm writing in slash 24.
Who's in the meeting room?
Oh, it's the what he's checking.
So directly I can write 0 dot 0 z 0 dot 255. So this is my wildcard mask.
Okay.
Opposite of subnet mask.
Opposite of it. Okay.
Okay, I think theory for today, theory is done. I'm telling about only for today. Theory is done. Just do, you know, one practical. If you have time, guys, do you have time? Or you are busy today?
Me?
Yeah.
Yeah, I just got it. But I'll be back in a few. I just got a call to come real quick. I'm still at work, but I'll be back in a few minutes.
Okay.
Yeah.
So should I do lab or not? Tell me.
I would love to see the lab. You about to do the lab now?
Yeah, yeah.
Okay.
So
I'll be back in a few minutes.
okay.
Okay.
No problem.
Thank you.